Okay, question 14. The weights of apples from Tony's farm follow a normal distribution with mean 158 and standard deviation 13. The apples are sold in bags that contain 6 apples. Find the mean weight of a bag of apples. Okay, that's pretty straightforward, guys, because the mean is just going to be 6 times 158. Because, let's do that, 6 times 158, 948. This is because, well, obviously, if one apple has a mean of 158, 6 apples have a mean of 6 times 158. Now that's, well, I say obvious, but part B is not, it's not as obvious because we're dealing with the standard deviation, which obviously acts a bit strangely, because this topic is about this is a combination of n random variables, and you'll see it in, it gives you the formula in the formula booklet, and the formula for mean is it's the expected value of x1 plus x2 plus x3 is equal to the expected value of x1 plus the expected value of x2 plus the expected value of x3. That's for the mean. And for the variance, it's the same thing. The variance of x1 plus x2 plus x3, sorry, I don't know why I put e there, plus x3 is equal to the variance of x1 plus the variance of x2 plus the variance of x3. But they're not asking for the variance, they're asking for the standard deviation. So I can't just do 6 times 13 to give me the standard deviation. What I have to do is get the variance first. So the variance equals 6 times 13 squared, because this guy, the variance of one apple is 13 squared. If the standard deviation is 13, the variance is 13 squared. So the variance for the bag is 6 times 13 squared, which is 6 times 13 squared, which is 1014. 1014, that's the variance. We need the standard deviation. The standard deviation is then the square root of that. So it's the square root of 1014. Let me just make it into a decimal. 31.8434. 31.8434. 31.8. 3 significant figures. Okay, part C. Find the probability that a bag selected at random weighs more than 1 kilogram. Right, that's a little tricky, a little bit of a sneaky thing there, guys. It's 1 kilogram. We're dealing with grams here, so just be careful. So I'm going to say x is now this new normal distribution with a mean of 948 and a variance of 1014. Remember here, guys, you put the variance, not the standard deviation. And we want to find the probability that x is more than 1,000 because it's kilograms. And this is going to be, so I need to go into menu, probability, distributions, normal CDF. My lower bound is 1,000 and my upper bound is 999999999. That's enough. My mean is 948, and my standard deviation is the square root of 1014. Note, guys, the square root of 1014. Note I put in that rather than that. Definitely don't put 31.8. If you put 31.8434, fine, but don't put that because that's the rounded value. So 0.051235, 0.051235, 3 significant figures, 0.0512. And that's it. That is question 14.